morning, everyone. I hope you're all having a wonderful time at ARPA-E. I definitely had a wonderful time yesterday walking through the hall and looking at all the great new technologies. Thanks for having me here today, and I hope I can give you an overview of what we're trying to do to make a big change in global greenhouse gas emissions in the world, a topic very near and dear to our member companies here. So I work for Climate Investments, as Ryan just mentioned, and our charter, actually, if you take a step back, the CEOs right after the Paris Accord, the CEOs of the 10 majors I show here, who contribute about a quarter of the world's oil and gas production, they got together and said after the Paris Accord that we've got to do something about climate change and something fast. So they formed OGCI, the Oil and Gas Climate Initiative. And in the middle of last year, they formed Climate Investments, the investment arm for OGCI. And our charter is to go out there and look for investments in technologies which can bring about change in greenhouse gas emissions in the world. So let me give you a little bit of an overview of what we do. We are a $1 billion fund, $100 million a year for over 10 years. And our charter is to find partners who are co-investors, who can be customers, who can be policymakers, so that we can accelerate the commercialization of the technologies we see which can impact global greenhouse gas emissions, and obviously get it to a scale where it makes global impact, significant impact in the world. So we have two main goals. Obviously, the number one goal we have is reduction of greenhouse gas emissions. And obviously, our number two goal is also have the financial returns, which we need. But I'll tell you what, if we can't deploy these technologies at world scale, right, we will never be able to get the massive reductions in greenhouse gas emissions. And the ability to deploy something at world scale almost requires financial return for the people who invest in it. So all the partners, all the companies investing in the technology, so financial return is important. So those are the two things we look at. The other thing we like to look at is as a system, right? We want to make sure that most of these problems are system problems, and we help with overcoming the hurdles associated with commercialization so that we can get it to be deployed. And obviously, our member companies provide a great avenue for deployment. And with our partners, we can also take it to the industry, outside the oil and gas industry, and get deployment done. So that's our goal, collaboration and moving with speed. All right, so having set the stage on what we do, on what we want to do and how we want to fund it, I'd like to jump into what our objectives are, what our main areas of thrust are. So these numbers, which I show on the slide, the 44 gigatons of CO2 a year, these are large numbers, gigaton equivalents, which includes both methane and CO2, methane in the form of CO2 equivalents. These are large numbers, and they are a little dated, but the fact is these numbers are large, right? And about 75% of it is from CO2, 15% from methane, and then you get the emissions from NOx and the fluorocarbons and all the other types of greenhouse gas components. Now, if you take a look at kind of a breakdown of where this greenhouse gas is coming from, roughly about 14% comes from transportation. A third comes from electricity, heat, and combustion. You get about 20% from industrial processes. And of course, agriculture contributes a quarter of the emissions here. Now, if you just look at the first three, which I highlighted here, that's about 70% of the emissions there. And in that 70%, the amount of CO2 to methane is roughly a 9-to-1 contribution, 90% being CO2. Now, we decided that the four key areas we're going to look at as we get things off the ground for climate investments is methane reduction, carbon capture, utilization and storage, energy efficiency, and transportation efficiency. So I'll spend the next 10 minutes or so walking you through what our thought processes in each of these four areas, what we're doing to make significant change in greenhouse gas emissions. So why methane? Obviously, methane is a very potent greenhouse gas. In fact, if you look at the 20-year time frame, methane is 84 times more potent than CO2 when it comes to greenhouse gas effects. And in the longer time frame, it's about 28 times or 28 times more potent. Now, obviously, a third of the greenhouse gas emission effect comes from methane, and we want to do something about methane with the same urgency as we do with CO2. If you look at the oil and gas change, there's obviously leaks everywhere, right? Right from where you look at exploration all the way down the chain to transportation and then getting it to the distribution network. There's leaks everywhere. In fact, if you look at what we do, what's coming off in fugitive emissions or in flare gas, slip-in flare gas, or looking at things which come off, pneumatic controllers or compression, or even in gas separations. These are all significant amounts of methane being lost. And obviously attacking that problem in multiple fronts is very important to get the amount of methane loss down and mitigated. So this is something we announced last week at CERAWeek, a Methane Ventures Day. So we want to put $20 million this year towards making investments on methane-related technologies. And we look at it as three distinct areas. The first area being detection, which kind of gives you a coarse view of which areas are producing the methane. Then we want to look at measurement, which quantifies in a more precise way as to the location and the amount being emitted. And obviously the key, mitigation. Once you find the methane leaks, what are the techniques which you can tailor to either equipment or area to get the leaks fixed, right? And the other thing which we are going to help greatly is we bring 10 member companies to the table in terms of deployment. So we'll be able to provide an avenue for deploying these technologies and piloting them and taking them through the process of getting used in a widespread manner. So as I mentioned, the Methane Ventures Day was announced, and our process we are going to follow is pretty straightforward. And if people are interested, I'd refer you to our website, oilandgasclimateinvestments.com, or the oilandgasclimateinitiative.com, sorry. So what we want to do is this. Between now and May 15th, we want to invite proposals, and we have a process for inviting it on our website. So once May 15th passes, what we'd like to do is go through a preliminary due diligence, and down select to the 10 or 15 companies which whom we'd like to invite into Washington on June 24th to pitch to us so that we can go through our due diligence process after that, the deep due diligence process after that, to down select and announce whom we are going to invest in by September 24th. So that's our plan. It's an aggressive initiative for us to get this whole methane measurement, detection, and mitigation off the ground. And we'd like to partner with all of you, and if you have great ideas, we'd like to see them and start getting methane off the ground for as fast as we can. Let me hit the next topic, which is carbon capture, utilization, and storage, a topic which ARPA-E has worked on a lot in the past. Now, if you go start looking at some IEA reports of the past, their prediction is 14% of the energy emission reduction in the longer term has to come from CCUS, which essentially implies that CCUS has to be able to get a gigaton per year of CO2 out by 2030, which means essentially hundreds of CCUS plants need to be built. So what we decided to do is to look at CCUS at a very system level. We took on a project from ETI, Energy Technology Institute in the UK, to do a feasibility study on a large scale, a world scale, which is about 5 times what's ever been done before, to look at all elements of CCUS in kind of a holistic fashion, right? Starting with power as an anchor, natural gas, power as an anchor, and then building the chain through CO2 capture, the shipping required to get to storage, and understanding storage elements, which is either saline formations or in depleted gas wells. So we want to look at this as a system. We want to partner with policymakers. We obviously want to bring investors into this one. We want to understand business models which will make it palatable for everyone to participate, including the policymakers, so that we can get the first one off the ground. More importantly, we want to look at a multi-generation plan where we look at cost out in all the elements, power, carbon capture, which require incredible breakthroughs for the costs to come down to make this feasible, to make this very attractive financially in the long run. So that holistic approach, partnering with with the government, partnering with some of our co-investors, understanding the feasibility of making this happen. So we are in the feasibility stage here. So it is the pre-feed. We haven't gotten into pre-feed yet, but we are still in the feasibility stage to understand all these elements and what it takes to bring something of this scale to the marketplace. Now, we also want to make it attractive enough for industrials to start to play a part, the fertilizer, the steel, the chemical industry of the world, so that they can utilize the shipping and the storage facilities in order to get to that world. So obviously that requires creating a conducive environment, working with policymakers to make this attractive proposition to do this and solve this big CO2 problem. Now, the other aspect I want to highlight is CO2 utilization, right? EOR is probably one of the biggest knobs to turn on CO2 utilization. That's wonderful. We'd also like to figure out ways where we can use CO2 and sequester it in products so that they have a different life cycle of their own. And I'll walk you through a few investments we have made over the last 5 months in technologies which do exactly that. So I hope I gave you an overview of this whole picture of what we want to do in CCUS. This is something first of a kind for us. About five times what's ever been contemplated before. So, and we are working through the feasibility of how to go about doing something under the umbrella of business models, policy making, all of that stuff, okay? Let me talk through 2 examples on CO2 utilization, which is a very important topic here. As I mentioned, EOR is something which is active, that's wonderful, that's ongoing. But here are 2 technologies which I'd like to highlight. The first one is in the cement industry, and cement contributes to about 6% of the CO2 emissions if you look at the numbers. So Solidia Technologies came up with some very interesting technology which sequesters CO2 in concrete. It uses CO2 as the curing agent rather than water. And what it does ultimately, the effect is it reduces the CO2 footprint on concrete by about 70%, and along the way comes a water reduction also, an 80% water reduction. So essentially, as this graphic shows, at full scale, when Solidia implements this, you're looking at 30 concrete blocks of Solidias, which will be equivalent to about planting a tree, right? About 22 kilograms of CO2 taken out a year. So that's a significant amount. And if you look at the amount of water saved, it's about 2 trillion liters of water. So significant impact at full scale. And we are very excited with this company on what they're doing, what they can do as they move this product on to commercialization and spreading this across the globe. The next technology I'd like to talk about is a company which we invested in just 4 or 5 weeks ago, a company by the name of Econic. As you all know, polyurethane industry is a pretty big industry. It's a 26 billion, 30 billion industry. And it essentially consists of 2 components, a polyol component and an isocyanate component. This technology goes towards the polyol component, right? One of the key ingredients in making urethanes. Urethanes are ubiquitous. You're using them every day, whether it's furniture and bedding or whether it's using it sitting on a car seat or using used as coatings, adhesives, and sealants, or even as coatings for frac sand, which is a recent application for urethane. So a number of applications, ubiquitous in healthcare markets, in automotive markets, in aerospace markets, in aircraft, everywhere. It's really a ubiquitous material. Now, this technology which Econic has come up with is very interesting. They make a polyether carbonate polyol, right? And polycarbonate polyol, introducing the CO2 linkage into a polyether backbone gives you some properties like abrasion resistance and better solvent resistance and all those properties. And Econic's beauty of their system is their catalyst can be tuned to give you different compositions of CO2 in the backbone. So it allows you to play with polyol formulations and get the right properties for customers, tune the right properties for customers. So this technology can also be retrofitted into current polyol technology because their catalyst activity is pretty good at 10 bar, which is the normal operation of how you run the polyol reaction when you run the propylene oxide or ethylene oxide reactions. So great technology put there, and what Econic is hoping for in the next 10 to 15 year time frame, they'll be able to take out about 3.5 million tons of CO2 a year, which is equal to about taking 2 million cars off the road, right? So good technology, which is progressing through its commercialization phase, working with customers and in the marketplace. So something which we wanted to highlight here. Let me switch over to the next topic I'd like to talk about, energy efficiency. Now, it's obvious that you get more efficient, you use less energy, you put less CO2 out. So this is the natural for us to work on here. And if you look at just the oil and gas, when you look at upstream, just the extraction and the exploration piece, you emit about a gigaton of CO2 a year. And if you look at the refining and the chemicals piece, there's a similar amount of CO2 to emitted. So we'd like to get efficient and bring technologies to bear in this arena, whether it is much, what we have found is components which use a lot of energy also emit a lot of energy. Compression, for example, uses a lot of energy. So we'd like to get more efficient on the compression side. We'd like to get more efficient on the power gen side offshore, right? A lot of the technology being used is open cycle, which is not very efficient, and we'd like to find alternates to that. And obviously in the refining section, making chemicals and refining use a tremendous amount of energy, and you have a lot of waste heat, and we'd like to come up with technologies which can use that waste heat and generate power with that waste heat, so reutilize some of the energy which is lost. So those are the areas of great significance we are looking at, and we're looking at companies which, and going through the due diligence on them to understand how they will bring value and where they are in their development stage and the commercialization stage. The last topic I want to hit is transport efficiency. If you look at the cars you drive, the EV market's coming on the passenger side. It's coming here to stay. And that serves about 60% of the market, the light vehicle, light truck market. What we'd like to focus on is the underserved market, the 40%, which is the heavy duty vehicles. And we'd like to bring efficiency in that, whether it's through engine technologies, whether it's through fuels which follow the engine technologies, whether it's with lightweighting. You just heard this video on aluminum and the important role aluminum plays in lightweighting. We'd like to look at aerodynamics and how can you decrease drag resistance. And we'd like to look at rolling resistance, all the things which tire manufacturers look at on rolling resistance reduction. So we'd like to look at this whole market very holistically. In fact, in one of your demos yesterday, you saw an investment we made in Achates Power. Very interesting two-stroke engines, opposed cylinders, which can bring incredible efficiency. They had a Ford F-150 out there on display which said there's going to be a 30% reduction, apples to apples, compared to the EcoDrive Ford engine in terms of emissions and fuel efficiency, improvement of fuel efficiency also. So Achates Power is something we've made an investment in. We're excited with this technology on where this can go and how it can bring change to the internal combustion engine. With that, I'd like to finish up with my last slide. Obviously, we're looking for partners. We need you on this journey, right? We need partners. We need all of you with great ideas, technologies to bear to bring this greenhouse gas emission reduction into play as fast as we can. So we need a sense of urgency here, and that's what we're trying to do, spark this sense of urgency and work hard and tirelessly to get greenhouse gas emissions down. So I want to thank you all for the attention you gave me today. And if you need any information, our website's right there, oilandgasclimateinitiative.com. And if you'd like to write to us or look us up on the website and give us a call or email us, it'll be wonderful. We are looking for a lot of great ideas, a lot of great companies. And we want you to partner in this journey. We want to partner with you in this journey as we bring greenhouse gas down. Thank you for your time. Appreciate your attention.